Welcome to the chapter 12 of Thermodynamics, and in part 1 you will learn about some basic terms related to thermodynamics and thermodynamics versus mechanics. Thermodynamics. Thermodynamics is a branch of science that deals with the concepts of heat and temperature and the interconversion of heat and other forms of energy. It mainly deals with the transformation of heat into mechanical work and vice versa. Its great success lies in the fact that it explains the bulk properties of matter in terms of few macroscopic variables such as pressure, volume, temperature, mass, and composition, which are easily observable and directly measurable. State of any thermodynamic system can be described in terms of certain known macroscopic variables known as thermodynamic variables. Thermodynamics versus mechanics. Mechanics you have already studied, and it deals with motion of a system as a whole. In fact, with center of mass under the action of several forces and torques. Whereas thermodynamics is not concerned with the motion of a system as a whole, it is concerned with the internal macroscopic state of the body. When a bullet is fired from a gun, we will consider the motion of bullet and its velocity, acceleration, etc. Now consider the second scenario where bullet is fired on a wall. When it hits the wall, its kinetic energy gets converted to heat. And due to heat generation, there will be a change in temperature and the internal energy of the bullet. These are the macroscopic variables which we will study in thermodynamics. Thus, you can say that in this case, temperature is related to internal disordered motion of the molecules of the bullet, not to the motion of the bullet as a whole. Types of equilibrium. In mechanics, equilibrium means the net external force and torque on a system are zero. The term equilibrium in thermodynamics appears an equilibrium state if macroscopic variables that characterize the system do not change with time. For example, a gas inside a closed rigid container completely insulated from its surroundings with fixed values of pressure, volume, temperature, mass, and composition that do not change with time is in state of thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium when all of its macroscopic variables are constant. A system in the state of thermodynamic equilibrium possesses thermal equilibrium, and the two systems are said to be in thermal equilibrium with each other if temperature of both the systems do not change with time. Chemical equilibrium. The system doesn't undergo any spontaneous change in its internal structure due to chemical reactions, diffusions, etc. And in mechanical equilibrium, there is no unbalanced force in its interior or between the system and the surroundings. Equation of state. Equation of state depicts the relation between the state variables, that is between pressure, mass, volume, density, and it describes about the state of matter under given set of physical conditions. For an ideal gas, the equation of state is PV is equals to nRT, where PV and T are the state variables and N denotes the number of moles. Any part of universe enclosed by some boundary through which exchange of heat or energy takes place is called a system. And any part of universe which is not a system is called surrounding. To understand it, let's consider an example that we are having some hot coffee in a kettle. Then the kettle is the system and everything else is the surrounding. So you can say that kettle with hot coffee constitutes system and everything else around it is surroundings. Types of systems. Open system. Whenever there is an exchange of energy and matter, then such type of system is called open system. For example, water is boiling in a pan without lid. But when exchange of matter doesn't take place, but exchange of energy takes place, then such type of system is a closed system. For example, a balloon filled with gas and a pot with a lid closed. Because in this case, heat is getting transferred from the gas to pot and also heat is transferred to the surroundings, but steam is not allowed to escape from the pot. Isolated system. In this system, neither there is a change in the matter nor change in energy. For example, any closed insulated vessel like thermos flask is an isolated system because in thermos tea can be kept hot for many hours because the walls of thermos are insulated and doesn't allow heat to flow out of the flask.